In this video, we're going to talk about Euclid's Book 1, Proposition 7. And the first thing he wants us to do is draw a line between point A and point B. And then he wants us to draw two more lines, one AC, the other one AD. And AC must be equal in length to AD. Then he wants us to draw two more lines, BC and BD. And then you're supposed to make sure the BC is equal in length to BD. And when you do, you're supposed to draw one more line between C and D. Alright? And when you do, you're going to form two isosceles triangles. Triangle ADC and BCD. Now these two triangles in themselves are not equal in size. That's okay. For what we're trying to do here, they don't have to be. But because they're isosceles triangles, that means that AC is equal in length to AD. Likewise, BC is equal in length to BD. Alright, because of this, and because of Proposition 1.5, which I talked about in a previous video, then you have two angles here, ACD and angle ADC, and they are equal in size. Alright, now here comes a chart. Hang on just a second here. We're now establishing the angle ADC is equal to angle ACD. Now, we're also going to show you, right over here, we're going to turn this diagram around, the angle DCB is a part of DCA. So actually you're going to say that angle DCB, which is right here, this little right here, is, because it's part of DCA, it's going to be smaller than DCA. It's also going to be smaller than CDA. Okay? So this little angle here is going to be smaller than this one or this one. Alright, because CDB is a part of DCA. And so therefore it's going to be really, really tiny. And we show that right here. Angle DCB is smaller than ACD. Now you say, okay, the angle starts at point D, goes through point C, and ends at point B. That's how those things are supposed to be read. Okay? Let's go on here. Angle DCB is also smaller than angle ADC. So therefore, BDC, angle BDC, is bigger than ADC. Now let's show you that one. Okay, we have an angle that starts at letter B, goes through point D, comes up through C. As you can see, ADC is a part of angle BDC. So therefore, BDC is bigger than angle ADC. It's also bigger than angle ACD. Alright, now then, since we said that angle BDC is bigger than angle ADC, and we also said that DCB is smaller than angle ADC, then we can actually say that angle BDC is bigger than angle DCB. And there comes the problem. You see this right here, BDC? There it is, BDC. You see how it has DCB? DCB. Okay. Now, let's take a look at our other isosceles triangle. We got a triangle BC and D. And because that BC is equal to BD, then we're going to start trying to say that angle BCD is equal in size to BDC. And we've already established that this angle over here and this angle over here are not equal in size. So now we have an absurdity. So therefore, if you have two lines AC and AD, and lines BC and BD, and they meet at two different points, one of these lines or more are not going to be the same size. It's that simple. Alright, and that concludes Proposition 1.7. Hopefully you weren't too badly confused. I will tell you more in a future video, so stay tuned.